So vector calculus, lecture 11. And let me remind you, the first midterm exam is next Monday in person on campus. Gillette Hall on the second floor, room 203. From 11 to 12:40, regular class time. In person. Must be there. And it covers everything that we've covered on the syllabus since the beginning of the term. And you have a review sheet, practice exam, and hope everyone got it. Are there any questions? Anything you would like me to go over from the homework or from the material? If not, maybe I'll just start going through some of the questions on this review sheet. So from the practice exam, let's look at number 1. Easiest place to start. We have two vectors, 2, 4, -1, and V is 3, 0, 7. So 3 times U minus V. What is 3 times U? You multiply each coordinate of U by 3. You get 6, 12 minus 3 minus V, which is 3, 0, 7. So when you subtract, 6 minus 3 is 3, 12 minus 0, 12, minus 3 minus 7 is minus 10. Okay. If you have any questions, just unmute and ask me a question. What about B? The dot product. So you multiply coordinates and add 2 times 3 plus 4 times 0 plus minus 1 times 7. 6 plus 0 minus 7 is minus 1. What is the cross product? Simplest way to remember it is to write the 3 by 3 matrix, 2, 4 minus 1, 3, 0, 7. So you get something times I, 2 times 7, 14, minus 3 is 17I, minus 21 minus 3 is 21 plus 3, 24J, plus 2 times 0 minus 12 minus 12K. Or if you want to write it just as the coordinates, 0 minus 24 minus 12. The length of a vector U is the square root of the sum of the squares of the coordinates. 2 squared plus 4 squared plus minus 1 squared. So it's the square root of 4 plus 16 plus 1. So that's the square root of 21. What's the cosine of the angle between U and V? So the cosine of that angle, let me just call it theta, is the dot product. Actually, let's just recall. The dot product is the length of U, the length of V, times the cosine of the angle between them. So the cosine of theta is the dot product divided by the length of U, the length of V. The dot product, I just calculated, it's minus 1. The length of U is the square root of 21. The length of V, I have to calculate that. Just do it right over here.
Sir, may I ask a question?
Yeah, of course.
Sorry, I was like out of like class for about a week and a half because I was at the ER room, just had to do something. So for the upcoming test, right, is it only based on the homework problems?
It's based on, well, um, it's based on the material that we covered. So the homework, it's based on what's on the syllabus in the book.
All right, perfect.
But as a practical matter, uh, if you can do the homework, if you can do the practice exam, you'll do well on the actual midterm.
In 6 days, I can do that, I hope. All right, let's
Okay,
continue.
right. So what is the length of V? It's the square root of 3 squared plus 0 squared plus 7 squared. That's the square root of 9 plus 49. That's the square root of 58. So that's the cosine of the angle between the two vectors. Let's look at the other parts. So this is still one part F. We have U is the vector 2, 4, minus 1. V is the vector 3, 0, 7. So, and we want to find the projection of U onto V. So the picture you should have in your head is here you have a vector V, here you have a vector U. If you were to think of this in space and you drop the perpendicular, this is the projection of U in the direction of V. What is that equal to? Well, if this is the angle theta between U and V, the cosine of theta is the length of this projection. It's this over this. That's the definition of the cosine. It's the length of the projection of U in the direction of V divided by the length of U. So the length of this projection of U in the direction of V, is equal to the length of U times the cosine of theta. That's almost the dot product. That's cosine U, cosine V, cosine theta over the length of V. I just multiplied and divided by the same thing. So this is the dot product of U and V divided by the length of V. And so we want a vector of this length going in the direction of V. So the unit vector in the direction of V is just V divided by its length. So the projection of U in the direction of V, it's a vector, this is the length, times the vector V over the length of V. So this is U dot V, which is a number, over the length of V squared. This is a number or a scalar, times V. So that's the formula for the projection. And what is it in this case? The dot product, well, we calculated that. Where is the dot product? The dot product is minus 1. The length of V was root 58. The square of that is 58 times the vector V, 307. So this is the projection of V in the projection of U in the direction of V. And finally, a unit vector parallel to u is u just divided by the length of u. Again, we calculated the length of u. Length of u is square root of 21 times u. So that's 2 over root 21, 4 over root 21, minus 1 over root 21. So this is a unit vector in the direction of u. Any questions about that?
Professor, I have a question.
Go ahead.
Can you explain why when we did the u, we did 1 over the square root of 21? I'm confused where the 1 is coming from.
In this problem?
Yeah,
Okay, so
where you did the 1 over square root of 21.
so the length of the vector u is the square root of 21. The way you get a unit vector in the direction of any non-zero vector is take the vector and divide by its length. So the vector is 2, 4, minus 1, and you're dividing by square root of 21. 1 over the square root of 21. It's dividing this vector by the square root of 21. You divide each coordinate by square root of 21. Right? This is the reciprocal of the length. If the length of u is square root of 21, 1 over the length of u is 1 over the square root of 21. I mean, that's where the 1, if you're asking where does this 1 come from, that's where it comes from. You're dividing by the length of u. Other questions? Okay. Problem 2. So we have the vectors. X is the vector 3, 4, minus 2. Y is the vector 4, minus 1, 4. If I take the dot product, that's the length of X, length of Y, cosine of the angle between them. But what is the dot product? Multiply coordinates and add. 3 times 4 plus 4 times minus 1 plus minus 2 times 4 is 12 minus 4 minus 8 is 0. So this is equal to 0, which means the cosine of theta is 0, which means theta is pi over 2 radians. That means you have a right angle. So orthogonal is just another word for perpendicular or normal, and that's what it is. Right. Question about that?
Yeah, I got a question. So why is 0 very important for like calculus, vector calculus? I've noticed a theme with 0.
Well, 0 is an important number, but it's no more important than 17 or minus 1,000. It's just a number. But if
But
the
0 specifically is just,
well, if the cosine of theta is 0, then theta is plus or minus pi over 2, for example.
Okay.
It's just a number. In problem 3, we have the vectors u, which is 4, 3, and the vector v, which is 1, 1. And we want to express u as a vector parallel to v. and a vector normal to V. So I want to write somehow U as a vector. This vector is parallel to V, and this vector is normal to V. So, so the problem is to write U as P plus N, where P is parallel to V, and N is normal or perpendicular or orthogonal to V. So to find the parallel, we need to find the component of U. So P is going to be the projection of the vector U on V. And this is equal to, you take the dot product of U and V divided by the length of V squared times V. Right? This is the formula for the projection.
Question.
Yeah, go ahead.
This is calculating the speed of the vector?
No, well, first of all, speed involves the derivative. There's no derivative here at all. There's no,
Okay.
the vector is not moving. Right?
I see.
All right. There's just, you have a vector U. That's U. We have a vector V. Actually, let me draw the picture right. And I want to write U as the sum of two vectors, one parallel to V and one perpendicular to V. So there is the right angle. And the parallel, the vector parallel to V is the projection of U onto V, which is the dot product of U with V divided by the length of V squared times V. So if I take U is 4, 3, V is 1, 1. The dot product U dot V is 4 times 1 plus 3 times 1 is 7. The length of V squared is 1 squared plus 1 squared, which is 2. So this is equal to U dot V, 7 halves V, or 7 halves times the vector 1, 1, or 7 halves, 7 halves. So this is the projection V. And the component N is going to be U minus the projection. U is 4, 3. P is 7 halves, 7 halves. So this gives 1/2 minus 1/2. That's what this vector is. So I have my vector U, which is 4, 3, is P plus N. And you can check the arithmetic. P is 7 halves, 7 halves, and N is 1/2 minus 1/2. And these two vectors are perpendicular. So this is the answer. Question about that? Okay. 1, 2, 3, page 4. And problem 4. So we have compute the area of the parallelogram with adjacent sides given by the vectors in three-dimensional space. U is minus 3i plus 2k. V is I plus j plus k. Right? So we have U, we have V, they form a parallelogram, and we want to find that area. And the area is equal to the length of the vector U cross V. Right? So I have to calculate the cross product and take the length of that vector. So the cross product, I write I, j, k. The second row are the coordinates of U. Minus 3, 0 times j, 2 times k. V is 1, 1, 1. So if I compute this cross product, I get 0 minus 2i minus 3 minus 2 is minus 5, minus 5 is plus 5, and minus 3k. That's the vector U cross V. And the length of that vector is the square root of 2 squared plus 5 squared plus 3 squared, which is the square root of 4 plus 25 plus 9, which is equal to square root of 38. So that's equal to the area. Right? If you take the cross product of two vectors, you get a vector whose magnitude is the length of the parallelogram they form and is perpendicular to the two vectors. Right. Any questions about that? In part B, we have a triangle with vertices 0, 0, 0, 1, 2, 3, and 6, 5, 4. So you can have a picture that looks like here's A, here's P, here's Q. You look at the triangle formed with those 3 points in space as the vertices. We want the area of the triangle. Well, the area of the triangle is half of the area of the corresponding parallelogram. Right? If you have a parallelogram and you draw a diagonal, you get 2 triangles, each has half the area of the original parallelogram. So the area of the parallelogram is the cross product of these 2 vectors. The vector from A to P is just this minus 0, 1, 2, 3. The vector from A to Q is the vector 6, 5, 4. So the area of this triangle APQ is half the area of the parallelogram that these vectors form, which would be the cross product of the 2 vectors AP and AQ. So I take that cross product and compute its length. Half the length is the area of the triangle. And what is the cross product? I compute the 3 by 3 determinant. 1, 2, 3, 6, 5, 4. So I have the coordinate of I is 8 minus 15 is minus 7i. Minus the coordinate of j, which is 4 minus 18 is minus 14, and minus 14 is plus 14. K, I have 5 minus 12 minus 7K. Or if you like, 7 times the vector minus I plus 2J minus K. So the length of this vector is, I take the sum of the squares of the coordinates, the square root of 7 squared, take that outside, 7, minus 1 squared, plus 2 squared, plus minus 1 squared. This is 1 plus 4 plus 2 is 6. So I get 7 square root of 6 over 2. And if I did the arithmetic correctly, that's the result. But the idea is, what you have to understand is, if you have a triangle, it's half of a parallelogram. The area of the parallelogram is the magnitude of the cross product of the vectors that are the sides of the parallelogram. So I compute the cross product, take the length, divide by 2, that's the answer. Okay. Questions about that? Problem 5, we have two vectors, 1, 2, 3, let's call them U, and another vector, minus 2, 4, minus 1. We want to find a vector orthogonal to them. Well, if you have two vectors, a vector orthogonal or perpendicular to them is just the cross product. Cross product has lots of uses, so this is simply another use of the cross product. So I have the determinant 1, 2, 3, minus 2, 4, minus 1. This is minus 2, minus 12, minus 14i, minus, minus 1 plus 6 is 5, so it's minus 5j. And k, I take 4 minus 4 plus 8k. So if this is correct, this vector, u cross v, is orthogonal to these two. So let's just check. Let's just take u, because two vectors are perpendicular or orthogonal if the dot product is 0. So let me take u with the cross product. So I multiply coordinates. I get 1 times minus 14 plus 2 times minus 5 plus 3 times 8. I get minus 14 minus 10 plus 24 is 0. So that checks. And let me take v dot product with u cross v. That's minus 2 times minus 14 plus 4 times minus 5 plus minus 1 times 8. This is 28 minus 20 minus 8, again 0, so that checks. So that worked out okay. Question? Number 6. Find the equation of the line through the point minus 3, 2, minus 1 in the direction of the vector v equal 1 minus 2, 5. So the parametric equations for the line x of t, y of t, z of t, x of t is minus 3 plus t. Y of t is 2 plus minus 2t. And z of t is minus 1 plus 5t. So when t is 0, you're at the point minus 3, 2, minus 1. And as t increases or decreases, you're moving in the direction 1 minus 2, 5. So that's the line. Okay. Questions?
Wait, Professor, can you go back to the other problem really quickly?
Sure. Which problem?
The last one that we just did.
This is just the formula for the parametric equations for a line through a fixed point in the direction of some non-zero vector.
Okay, thank you.
In problem number 7, in space, you have two vectors, u and v, and you want to find the equation of a line that's perpendicular to both of them. So you want the line through this point, which is the origin, 0, 0, 0, perpendicular to u and v. U is 1, 0, 2. V is 0, 1, 1. So how do you find a direction perpendicular to both u and v? Again, you take the cross product. U is 1, 0, 2. V is 0, 1, 1. So when you take that cross product, the coefficient of I is 0 minus 2. Let's see, this determinant is 1, so it's minus 1 times j. And what is the coordinate of k? It's also 1. So the vector u cross v is perpendicular to both of these vectors. So the parametric equations for the line are, this line are x of t is minus 2t, y of t is minus t, and z of t is 1 times t. That's it. Okay. Number 8. So an equation of a plane, the way to describe the plane is you have a point P on the plane and a normal vector. And your plane consists of all the points let's say Q, where the line from P to Q is perpendicular to this normal vector. So if you have a normal vector and a point, you can determine the equation of a plane. So we want to find the plane passing through the point P with coordinates 0, 2, minus 2, with normal vector 1, 1, minus 1. So if you take a point Q with coordinates x, y, z, and P has coordinates 0, 2, minus 2, the vector from P to Q will have coordinates x minus 0, y minus 2, z minus 2, that's z plus 2. And we want, so x, y lies on the plane if the dot product of P and Q with the normal vector is 0. So we're taking the dot product 1, 1 minus 1, dot product with x, y minus 2, z plus 2. That's equal to x plus y minus 2 minus z plus 2. That's equal to x plus y minus z. I have minus 4. We want that equal to 0, or x plus y minus z equals 4. So that's the equation of the plane. The point 0, 2, minus 2 satisfies this equation, and any point that satisfies this equation lies on the plane. Okay. Questions? Okay. So after problem 8 comes problem 9. So problem 9, we want to again find the equation of a plane passing through 3 given points. So we have the point 1, 0, 3, the point 0, 4, 2, and the point 1, 1, 1. These are 3 points in space, and we want to find the plane going through them. Well, we have to find a normal vector. So this is, for example, 1, 0, 3 is one point that lies in the plane. And if this vector is in the plane and this vector is in the plane, then the cross product, let's call this P, Q, and R. So if I take the vector from P to Q, 1, 1, 1 minus 1, 0, 3 is 0, 1 minus 2. And if I take the vector from P to R, which is minus 1, 4, minus 1, a normal vector to the plane will be parallel to the cross product. So I need to compute the cross product of PQ and PR. I, J, K. PQ has coordinates 0, 1, minus 2. PR has coordinates minus 1, 4, minus 1. What is the cross product? Let's see. For the coordinate of I have minus 1 plus 8 is 7i. For the coordinate of j, I have the determinant 0 minus 2, so it's minus 2 is plus 2j. And for the coordinate of k, it's 0 minus 1, so it's just 1. So the normal vector to the plane is 7, 2, 1. And you can check this vector is perpendicular to both of these vectors. So the plane consists of all points such that 7 times x minus 1 plus 2 times y minus 0 plus 1 times z minus 3 is equal to 0. This is 7x plus 2y plus z minus 7 minus 3 minus 10, or 7x plus 2y plus z equals 10. That's the equation of a plane, and you can check. If you put in 1, 0, 3, you get 7 plus 3 is 10. If you put in 1, 1, 1, you get 7 plus 2 plus 1 is 10. If you put in 0, 4, 2, you get 0 plus 8 plus 2 is 10. So this equation is satisfied by all three of the points that we had to get on the plane. So we've done it. It works out very well. Okay. Questions? Number 10. You want to have a line segment, not an infinite line, but a line segment that starts at the point minus 1, minus 3, and ends at the point 6, minus 16. So the vector from P to Q is 6 minus 1, minus 16 minus 3 is this. So a line starting at P and going to Q would have coordinates, parametric coordinates. X of t is minus 1 plus 7t. Y of t equals minus 3 minus 13t as t goes from 0 to 1. When t is equal to 0, you're at minus 1 minus 3. When t is equal to 1, you're at 6 minus 16. So those are the parametric equations of the line. If you sort of wanted to draw it more to scale, if this were 4, 8, minus 4, minus 8, minus 12, minus 16. So the point minus 1, minus 3 would be about there. The point 6 minus 16 would be down there. And we want to find the line segment that goes from here to here, and it's given parametrically by these equations. Right, that's what it is. Number 11, we want to find the parametric equations for a circle centered at the origin with radius 7. And generated counterclockwise. So the parametric equations, x of t, y of t, you just let x of t be 7 cosine t, y of t is 7 sine t, as t goes from 0 to 2 pi. When t is equal to 0, you're here. And as t increases, you're moving around the circle counterclockwise. And at 2 pi, you're back exactly where you started. Questions? Okay. After 11 comes 12. So in 12, we want to go from Cartesian to polar and polar to Cartesian coordinates. So we have a certain point P whose polar coordinates are 2 pi over 3. So that's a point whose distance to the origin is 2, but makes an angle of 2 pi over 3 with respect to the positive x-axis. So this is the point. These are the polar coordinates. What are the rectangular coordinates? Well, if this angle is, so in general, you have, this is the angle 2 pi over 3. That means this is the angle pi over 3. This hypotenuse is 2. For what is this x distance? This is the cosine. So if I call this x, x over 2 is the cosine of pi over 3. Of course, it's in the negative direction, so minus x over 2 is the cosine of pi over 3. You have to know what is the cosine of pi over 3. Cosine of pi over 3 this is, so you have to know the basic angles, right? This is pi over 3. If this is 1, this is a half, and this is root 3 over 2. So cosine of pi over 3 is root 3 over 2. So x is equal to minus square root of 3. And y, if we have this triangle, oops, I'm sorry, I did something wrong. In this, if this is the angle, pi over 3, if this is 1, this is a half, and this is root 3 over 2. Okay? This is the angle pi over 3. This is a half, and this is root 3 over 2. So this is equal to a half. So x equals minus 1. Right? Let me just draw this picture again. If this angle is 2 pi over 3, this angle is pi over 3, because this plus this adds up to pi. So I have a triangle, pi over 3. The ratio of the sides, this is 1, this is a half, this is root 3 over 2. This is your pi over 6, pi over 3, or 30, 60, 90 right triangle. So minus x over 2 is the cosine of pi over 3 is a half, so x is minus 1. And y over 2, y over 2 is the sine of pi over 3, which is root 3 over 2. So y is the square root of 3. So for the point 2 pi over 3 in polar coordinates, this is minus 1 root 3 in rectangular coordinates. Okay. And to go in the opposite direction, if you have a point 1 root 3 in rectangular coordinates, this is the point. What is it in polar coordinates? So the distance to the origin is square root of 1 squared plus root 3 squared is the square root of 1 plus 3 is the square root of 4 is 2. So r is equal to 2. And what is this angle theta? Well, we just saw that. This angle theta is pi over 3. So the point 1 root 3 in rectangular coordinates is the point 2 pi over 3 in polar coordinates. Right. Questions about that? Okay. In problem 13, I see I left out a word. So problem 13 is a problem where to go back and forth between Cartesian coordinates and cylindrical coordinates. So in 13a, we have the point 1, 1, 1 in rectangular or Cartesian coordinates. And when I want to find the cylindrical coordinates for that point. So if you go 1 unit in the x direction, 1 unit in the y direction, and 1 unit in the z direction, this is the point with Cartesian or rectangular coordinates 1, 1, 1. So to find the cylindrical coordinates, I need to drop the perpendicular to the xy plane and find the polar coordinates of this point. Now, when I drop this point 1, 1, 1 into the xy plane, that has coordinates 1, 1, 0. So if I'm looking at the xy plane, here's the point 1, 1, here's 0, 0. The length of this line, r, is the square root of 2. This angle is pi over 2, and the height above the xy plane is 1. So the cylindrical coordinates r theta z are square root of 2. Sorry, this is pi over 4. Pi over 4, 1. So the point 1, 1, 1 in Cartesian coordinates is sent to the point square root of 2 pi over 4, 1 in cylindrical coordinates. And if I take the point 1 pi over 4, 1, if these are the cylindrical coordinates of a point, what are the rectangular coordinates? So if these are the cylindrical coordinates, that means in the xy plane, I have a point whose distance to the origin is 1, and who makes an angle of pi over 4 with the positive x-axis. So I have this isosceles right triangle. The sides will be 1 over root 2, 1 over root 2. So the xy coordinates of this projection of this point down into the xy plane are 1 over root 2, 1 over root 2. And this z is just the rectangular Cartesian coordinate of the point. That doesn't change, it's 1. So this is the Cartesian coordinates. 1 over root 2, 1 over root 2, 1.
Professor, can you go over number 12 again, please?
Sure. So in number 12, we have a point with coordinates 2, 2 pi over 3, polar coordinates. So where is that point? It means, first of all, the distance to the origin is 2. So this side lies somewhere on the circle of radius 2, centered at the origin. And the ray to that point makes an angle of 2 pi over 3 with the positive x-axis. So this is the line where this angle is 2 pi over 3. So we're looking for the point on this line, a distance 2 pi over 3 from the x-axis, sorry, a distance that makes an angle of 2 pi over 3 with a positive x-axis. So that's the point we're looking for. We need to find its coordinates. So this distance is 2. This angle is 2 pi over 3. That means this angle is pi over 3. With this plus this adds up to pi. So I have a triangle. This is pi over 3. This is 2. So we know that we know the angles. We know this. You have to know the sine and cosine of pi over 3 and pi over 6. If you have a triangle, a right triangle with an angle pi over 6, the opposite side is half the hypotenuse. So if this is 2, this is 1. And this squared plus 1 is 2. This is the square root of 3. So the sides of this triangle are 1 and the square root of 3. But this point lies in the second quadrant, so the x-coordinate is negative. So this will have Cartesian coordinates minus 1 root 3. I mean, you have to know this triangle, of course. And if you have the point whose rectangular coordinates are 1 square root of 3, this is the square root of 3, this is 1, this is a right triangle. So this is 2, and this angle is pi over 6. So these are the Cartesian coordinates, or the rectangular coordinates. In polar coordinates, this is 2. Sorry, this is pi over 3, this is pi over 6. Pi over 3. Other questions about that?
Thank you.
Okay, then is number 14. So now we're getting to vector valued functions, which is the most important material that we're covering in this exam. So we have a vector value function R of t. Cosine t log t 4t cubed plus 1. So the derivative, you just differentiate each coordinate. Derivative of the cosine is minus the sine. Derivative of log t is 1 over t. Derivative of 4t cubed plus 1 is 12t squared. That's the derivative. What is the integral of R of t? You integrate each coordinate. Integral cosine t dt, integral of log t dt, integral of 4t cubed plus 1 dt. The integral of the cosine is sine t. Integral of log t is t log t minus t. The integral of 4t cubed plus 1 is t to the fourth plus t. Right? Plus any constant vector, but this is the indefinite integral. And if you want to find the integral from e to pi of R of t dt, we're just integrating each of these functions from e to pi. So this would be sine t evaluated from e to pi, t log t minus t evaluated from e to pi, t to the fourth plus t evaluated from e to pi. So you get some algebraically messy thing. Of course, sine pi is 0, so this is just minus the sine of e. When t is pi, you get pi log pi minus pi minus, and when t is e, log e is 1. T minus t is 0, so when you let t equal e, you just get 0. And here you get pi to the fourth plus pi minus e to the fourth minus e. So you get some weird expression like that. Right. Number 15, we have a curve. Take a piece of paper. For problem 15, we have a curve, R of t is 2 sine t, 3 cosine t, sine of t over 2. The tangent vector is just the derivative. So r prime of t is 2 cosine t minus 3 sine t, a half cosine t over 2. And when you evaluate this at pi, because you want to find the tangent vector at pi, 2 cosine pi is minus 2. Sine pi is 0. Cosine pi over 2 is again 0. So the tangent vector is just minus 2, 0, 0. Number 16, we have a curve given by R of t equals 1 minus t squared. 3 plus 2t cubed. So if that's the position of a particle time t, the velocity is just the derivative, minus 2t, 6t squared. Right? Velocity is derivative of position. Acceleration is derivative of velocity. Differentiate this again, get minus 2, 12t. Okay. Any questions about this? Number 17. So you shoot a particle up into the air, starting at the point 0, 0, with some initial, so the initial position x0, y0 is 0, 0. You shoot it up into the air with an initial velocity, say u0, v0 are the coordinates of 10, 20. So this is in feet, and this is feet per second. So the particles are going to go flying in some parabolic arc. And so it hits the ground. So we want to find so I want to write, want to compute r of t, position of the particle at time t. And I want to find out at what time it hits the ground, at what point it hits the ground, and its maximum height in its trajectory. So what do we know about the motion of a particle operating under only the force of gravity, which is pulling it down? So the force of gravity is 0 minus mg, right? So that's a force going down. M is the mass of the particle. G is 32 feet per second squared. And force is mass times acceleration. And that's going to be 0 minus mg. You can cancel the m's. You get the acceleration is minus mg. And acceleration is the derivative of the velocity. So we have r of t. The velocity is r prime of t. The acceleration is v prime of t. And minus g. So the derivative of the velocity is the acceleration is 0 minus g. So the derivative of the velocity, which is the acceleration, is 0 minus g. So if we integrate, the velocity is some constant, u0 minus gt plus v0, right? The antiderivative of minus g is minus gt plus v0, which is u0 is the initial velocity 10 minus 32t plus the initial velocity's y component 20. So that's r prime of t. So r of t, the position of this particle is 10t plus x naught, we're integrating, minus 16t squared plus 20t plus y naught. Of course, x naught, y naught, the starting position are 0. So we get 10t minus 16t squared plus 20t. So for this particle, the position at time t is 10t minus 16t squared plus 20t, if I did my arithmetic correctly. So when does it hit the ground? Particle hits ground when the y-coordinate is 0. Minus 10t squared plus 20t equals 0. That's the same as minus 10t. I can factor that out. T minus 2 equals 0. So t equals 0 or t equal 2. T equals 0 is when it starts. It's at ground level. 2 seconds later, it hits the ground again. So the time of the flight is 2 seconds. What is the distance it's traveled? Well, the position when t is equal to 2 is 20. When t is equal to 2, minus 4 is 0. So the distance of the flight, the range, is 20 feet. And what is the maximum height? Y of t is minus 10t squared plus 20t. How do I find the maximum? I differentiate and set the derivative equal to 0. The derivative is minus 20t plus 20. That equals 0 when t is equal to 1. And y at 1 is minus 10 plus 20 is 10. So 10 feet is the maximum height. And that's the answer. Problem 18 is to find an arc length. So the arc length for a curve from time A to time B is the integral from, in this case, t is going from 0 to 1, square root of x prime. Well, let me start this on a new page. It's the best thing to do. So what is the formula for arc length? You have a curve r of t, x of t, y of t, z of t, t going from A to B. So here's r of A. Here's r of B. What is the arc length? The arc length, L, the integral from A to B of the square root of x prime of t squared plus y prime of t squared plus z prime of t squared dt. If it's in 3 space, if it's in 2-dimensional space, there's just no z of t. So in the first case, we're in 2 dimensions. R of t is 3t squared minus 1, 4t squared plus 5. So r prime of t, when you differentiate, you get 6t, 8t. This is x prime, this is y prime. So the length, and we're going from 0 to 1, is the integral from 0 to 1 of the square root of 6t squared plus 8t squared dt. That's the integral from 0 to 1 of the square root of 36t squared plus 64t squared dt. That's the integral from 0 to 1 of the square root of 100t squared dt. Square root of 100t squared is 10t. The integral from 0 to 1 of 10t dt. That's 10. The integral of t is a half t squared from 0 to 1. That's 10 over 2, or 5. So this curve has length 5. And in part B, we have a curve in three-dimensional space. R of t is 3t minus 1, 4t plus 5, t. R prime of t, when you differentiate, you get 3, 4, 1. So the arc length L is the integral from 0 to 1 of the square root of 3 squared plus 4 squared plus 1 squared dt. 9 and 16 is 25 plus 1. That's the integral from 0 to 1 of the square root of 26 dt. It's just the square root of 26. Oh, wow. Okay, so we actually did the whole review sheet.
Professor, in number 16, did we ever calculate the speed?
Oh, let's see. Let me go back and find number 16. Oh, sorry. So in number 16, R of t is 1 minus t squared, 3 plus 2t cubed. The velocity is minus 2t, 6t squared. Speed is the absolute value, it's the length of the velocity. So that's the square root of minus 2t squared plus 6t squared squared. So that's the square root of 4t squared plus 36t to the fourth, in which I can simplify that a little bit. I can factor out 4t squared times 1 plus 9t squared. So that's 2t times the square root of 1 plus 9t squared. Well, speed is just the magnitude of the velocity vector. Thank you. Questions above and beyond? Again,
Approximately how many questions are going to be on the exam?
I'm not sure exactly, 7 or 8 roughly, but I always put on some extra credits, and so there's some extra questions so you can get extra credited. Or if you like, you can always leave out one or so and still get a A on the exam. Yeah, that's the way.
Okay, and are there any problems on the practice exam that you think we should study
any
extra
questions
hard
on what?
for? Are there any questions on the practice exam that you think that we should prioritize or study harder on those questions?
Well, the most important parts are actually the last few questions on vector valued functions in calculus, because that's what we're going to be doing for the rest of the semester. But there will be questions on everything. But there will definitely be questions like 14 to 18. The material from chapter, I forget what it is, chapter 13 maybe, but the material on vector valued functions and their calculus, derivatives, and integrals. Because that's really the beginning of vector calculus. Up until that point, we were just learning about vectors, but it's calculus from now on.
Okay, thank you.
Mm-hmm. Again, I remind you, I have problem sessions tonight and tomorrow at 7 and Friday afternoon at 4:30. And if you have questions, I encourage you to log on and say hello and ask whatever questions you might have. If there's nothing else, then we are done for the day.
All right, sir. Take care.
Okay.
Thanks.
See you all on Monday. Bye all.